now in addition to the LED board, we need a driver board. And I've made this driver board in two versions. I'm calling this basically the golf cart version, and I'm calling this the RV version. While they're almost identical, there are actually a couple distinct differences. The main difference, other than the obvious size difference, is that the RV version uses this little rotary switch. And this rotary switch will mount here. And it is a 5-position switch, and it will give you 5 different sequences that you can go through, or 5 different LED patterns, depending on the orientation of the switch. In the golf cart version, and the reason I'm calling it a golf cart version is because I'm actually putting it on a golf cart, there are 2 switches that connect to here, and those 2 switches can both be on, they can both be off, or either one can be on or off, which gives you 4 different options. As far as the case goes, the RV version goes into a generic 80mm by 71mm by 25mm aluminum box, and I bought this from eBay, and the box is about $5, and it looks like this, and it just basically slides in to this box like that. Like that. Now, another thing you may notice is that there are 6 capacitors here, while there are 3 here. And the reason for that is these capacitors are quite tall. They're about 1 inch tall, and I could not find a box that was 1 inch high to accommodate them. So I'm using smaller capacitors, and these capacitors are half the value, but by doubling up on them, I get the equivalent value. And as you can see, these capacitors will fit in that box. So that's one of the other reasons why this actually is got more components on it than this one. Now this one uses a Hammond 1591 XXLSFLBK, and that's what this is. And this circuit board has screw holes to fit into the little bosses in the top of the box, and then the bottom just fits on here like so. There we go. So then we have a self-contained box, and then you'll have to punch a couple holes in here with some grommets, you know, for the wires to go in and out. Whereas with this one, there's actually a connector on here. So it's just a matter of you know, how I decided to make 2 different versions. Now, one other distinction is, especially with this one, you don't have to use this with the Cylon strip I made. This can be used for any type of addressable LEDs. For example, you can buy strip lights that are addressable, and this will drive them in some situations. Now, the first issue you're going to run into is, since we are powering the LEDs from here at 5 volts, how many LEDs are we able to power? Well, in this one, as it sets, we can get between 1 and 1/2 amps out of this power supply, depending on the source of manufacturer that you buy the regulator from. And that will handle 30 to 60 LEDs. And unfortunately, a lot of strips are more. For example, if you're going to put some addressable LEDs across your awning, you're probably going to have about 200 of them. And this is not sufficient to drive that. But there are options. One option would be to use a slightly more powerful voltage regulator. Now, this regulator is the one I'm using now. This is called a 7805 or a LM7805. Depending on the actual brand of this regulator, it can either output 1 amp or 1.5 amps. For example, the Texas Instrument version usually is rated for 1.5 amps. Some of the other brands are only rated for 1 amp. You can replace that with this one. This is a 78S05, so there's an S in the part number. Again, 7805, 78S05. This one will do 2 amps. And it is pin compatible. Can use the same heat sink and everything else, so you can directly swap this one for this one. And this will get you up to about 100 LEDs. Now, if you have to go further, another option is to use this module, which is actually a DC to DC converter. 12 volts go into here, and then the output is 5 volts at 10 amps. And you can run up to, say, 500 or more LEDs. But of course, if you want to use, say, red, you're going to use much less current than if you used all three colors plus white at the same time. The way you would wire this is that the LED strip has 3 wires, 3 connections. A positive connection, a negative connection, and a data connection. Now, to get this to work, you'd want to connect the negative output of this to the negative output of this, so you have a common ground. And then you'd want to connect the positive to the LEDs, and then you'd want to connect a data line from here to the LEDs. We're going to essentially power the LEDs from this module, and we're going to give the LEDs the data instructions from this module. And at some point, you might think, well, maybe I should build a new circuit board to put all this into one, which you can do. Or you can put them on, a little piece of fiberglass. And especially if you're going to use this in an RV, say, to power your awning, you may want to put this behind, say, your instrument panel with a switch out front. And the switch is going to be able to control 4 different sequences. And so I'm just kind of giving you an idea of other things that you can use this circuit board for. And on my website, I'm going to go into much more detail on how you could do something like this. Because the website also has construction tips, bill of materials, and everything else is necessary to build this. So you can actually use this one for many, many different purposes. So you kind of get the idea of how these things are put together. So I'm not going to go through a step-by-step assembly. So now we have the 2 circuit boards populated, and in both cases I've not put the AT1085 in yet because we have to program it. But just to kind of show you on how these things fit together. The first one, this is the 1591 Hammond case, and this just fits in here real nice. And there's 2 screws that will hold this down. And then the cover goes on, of course. And then you have a nice little box. And for this one, we simply slide this in. And again, you can see where the capacitors just fit. And then we do have this end that goes in. And then we have a knob that goes on. And then the way this works is we have light, which is the white light. This position is C, which means the Cylon Eye. M is a marquee type sequence pattern. R is a rainbow pattern, and S is a sequence, which means it goes alternately through these 3. So it does Cylon for a while, it does Marquee for a while, it does Rainbow for a while, then it goes back to Cylon. And of course, this is all in programming. You can change whatever you want to change. And then on this side, it's going to be a connector that connects in here to make the connection.